Welcome to educator.com. This lesson is about solving equations by adding or subtracting. In this lesson, you're going to learn about solving equations by adding or subtracting fractions. Applications are a builder wanting to know construction measurements, or even someone working on a project, or measuring rainfall. You're going to learn to isolate the variable. And that means to get the variable alone on one side of the equation. In order to solve an equation, your goal is to eventually have the variable alone so that you can see its value. Let's try solving some equations with fractions. N plus a half equals 11 over 12. So let's look at the side with the variable, which is the left side here. The opposite, or the inverse, of adding a half is to subtract a half. So we're going to subtract a half from both sides. A half minus a half goes away to 0. So then we've isolated the variable. N is by itself. Now on this side, just as in adding or subtracting fractions, the denominators need to be the same. So let's do that first. They can both become 12. So I'm going to do 2 times 6 and 1 times 6. So then I have 11 over 12 minus 6 over 12. 11 minus 6 is 5, and the denominator stays the same, 12. So n equals 5 over 12. Let's try another problem. We have 3 over 5 minus a equals 13 over 20. You could also make the denominators the same before working with a fraction. So here I'm going to make 5 the same as 20 by multiplying by 4. So on top I have 3 times 4. I get 12 over 20 minus a equals 13 over 20. So I've made the denominators the same. Now, many of us may look at this equation and think that we're working with a subtraction. But remember that the operation that goes with the number is the operation that is in front. So this is in fact a positive 12 over 20. So the opposite of adding 12 over 20 is to subtract 12 over 20. 12 over 20 minus 12 over 20 simplifies to 0, and we have negative a. So we've almost isolated the variable, but it still has a negative along with it. 13 subtract 12 is 1 over 20. So now at this point you have negative a equals 1 over 20, but we want to get it to where we have just a completely isolated, a alone without the negative sign. So I'm going to multiply both sides by a negative 1. Because multiplying by 1 won't change the value, but the negative and the negative will now make it into a positive a. And so on the left side, on the right side here, I have negative 1 over 20. Let's try writing the equation. You hammer a nail 2 1/4 inches long through a board. On the other side, 5/8 of the nail pokes through. How thick is the board? So we're going to take 2 1/4 inches. We're going to subtract the thickness of the board. I'll call that T. That's what we don't know. Remember, the variable always represents what we don't know, and in this case it's the thickness of the board. And once you take out the thickness of the board, you're going to still see 5/8 inches of the nail coming through. So now we can work with our equation. We've set it up. 2 1/4 is the total length of the nail. Subtracting out the thickness will show us what's left over, which is 5/8. I'm going to take the 2 1/4 and make the denominators the same. Remember that in adding and subtracting fractions, it may not be necessary to change the fraction into an improper. So I'm going to leave it as 2 1/4 for now. I'm going to change this times 2 times 2, so I have 2 and 2/8 minus t equals 5 over 8. And once again, you look at the fraction and the value in front, which is an imaginary positive here. So the opposite would be minus 2 and 2/8. Subtract 2 and 2/8. This cancels to 0, and I get negative t equals. All right, just as in subtracting integers, you have to look at the signs here of the fractions. One's a positive and one's a negative. If you remember, in subtracting integers, when the signs are opposite, you have to subtract. So I'm going to take 2 and 2/8 and subtract 5/8 from it. In this case, I will need to borrow, so this becomes a 1. The 1 that I borrowed from this 2 is actually 8 over 8. Remember, 8 over 8 equals 1. So that's the 1 that I borrowed. I'm going to take these 8 and add it with this 2 that I already had, and that now gives me 10, which will be plenty to take away the 5. 10 minus 5 is 5, keeping the denominator 8, and I bring down my 1. So now I have 1 and 5/8. Going back to our problem here, notice the negative was larger, so it's a negative 1 and 5/8. Now the board is not negative 1 and 5/8 thick, so let's get rid of this negative sign here by multiplying with a negative 1. The negative and the negative will give me a positive t, and the negative times the negative will give me a positive 1 and 5/8. So the board was 1 and 5/8 inches long. If we did this correctly, it should be smaller than the nail, because remember that an extra part of the nail was poking through the board. And if we look here, yes, 1 and 5/8 inches is smaller than 2 and 1/4 inches. Let's try solving an equation with a mixed number. 3 and 2/5 equals x minus 12 over 25. Okay, I'm going to start off by making the denominators the same. 5 and 25 can both be 25, so I'm going to multiply by 5 here. 3 and 10 over 25 equals x minus 12 over 25. The opposite operation, or the inverse operation of subtracting 12 over 25, is to add 12 over 25. So 12 over 25 minus 12 over 25 simplifies to 0. I've isolated the variable, gotten x alone. And over here, we have 3 is the whole number and 22 over 25. 22 over 25 can't be simplified, so let's just write it algebraically. X equals 3 and 22 over 25. Let's try another example. 9 and 5/8 plus b equals negative 3/4. I'm going to make my denominators the same here. 8 and 4 can both be 8. I would multiply by 2, and I can keep this one the same. 9 and 5/8 plus b equals negative 4 times 2 is 8, and 3 times 2 is 6. Now I want to concentrate on the side with the variable, which would be the left side here. The opposite of adding 9 and 5/8 is to subtract 9 and 5/8. 9 5/8 subtract 9 5/8 simplifies to 0. So I reached my goal of isolating b. Just as in with subtracting and adding integers, when your signs are the same, you're going to add up the numbers. In this case, my sign is the same. Both of them are negatives. So I'm going to bring down the negative 9 and add 6 plus 5 is 11 over 8. I can't leave my answer like this because I have an improper fraction here. So let's simplify that. 8 can go into 11 once, with a remainder of 3. So this is my new 1 whole. I'm going to add that to the 9 here. 9 plus 1 is going to be negative 10 with 3 over 8. So b equals negative 10 and 3/8. Let's try some equations with inward problems. Your teacher asks you to choose, let's see, your teacher here, asks you to choose one of the 3 lunches: spaghetti, a turkey sandwich, or chicken salad. If 2/5 of the class chooses spaghetti and 1/4 of the class chooses a turkey sandwich, what fraction of the class chooses a chicken salad? So 2/5 chooses the spaghetti, 1/4 chooses the turkey sandwich. What fraction is choosing the chicken salad? What we don't know is the chicken salad, so let's call that C. And if we add up all the portions, that will equal the 1 whole, the entire class. So first let's add these 2 fractions. And we need to make the denominators the same. They can both be 20. Multiply by 4, multiply by 4. I get 8 over 20. This one I'm going to multiply by 5 and multiply by 5. 5 over 20. Plus the people who chose the chicken salad will equal the entire class. 8 plus 5 is 13 over 20 plus c equals 1. Now I'm going to subtract 13 over 20 from both sides so that I can isolate the c, get the c alone. These cancel out to 0, and I have c equals 1 minus 13 over 20. Well, I'm going to change 1 into a fraction by putting it over a 1. And then I'm going to make the denominator 1 the same as 20 by multiplying with 20. So C equals 20 over 20. And I'm going to subtract the 13 over 20. And C equals 7 over 20. Let's go back and check. If I have 7 plus 5, that gives me 12, and 12 plus the 8 will give me 20. So then I would come up with the entire class, 20 out of 20 people. So the amount of people that chose the chicken salad is 7 over 20. Let's try another example of writing an equation with fractions in a word problem. A designer has 15 3/4 yard of fabric. The designer uses 3 1/5 yard on a dress. How much fabric does the designer have left? So you have the total amount of fabric, which is for 15 3/4, and the designer uses up 3 1/5 yard on the dress. How much fabric does the designer have left? So there are several ways to set up this equation. You could take out what the designer has left, and that would equal what he's used up, 3 1/5. Or you could write it very straightforward and just say 15 over 3/4 minus 3 1/5, what he used up, leaving what's left over. Either way, the equation will give you the same answer. So let's work out the equations both ways and see how we get the same answer. So 4 and 5 can both be 20, multiplied by 5, multiplied by 5. I get 15 and 15 over 20 minus, multiplied by 4, 3 and 4 over 20 equals what's left over. 15 minus 3 is 12, and 15 minus 4 is 11 over 20. So the leftover portion is 12 and 11 over 20 yards. Now let's try it in this equation, which is going backwards, taking out what's left over to equal what was used up. So I'm going to make the denominators the same once again, times 5 times 5. That'll give me 15 and 15 over 20, and minus what's left over, and times 4 times 4. That will give me 3 and 4 over 20. Now the opposite of adding 15 and 15 over 20, remember not to look here because that negative goes along with the 11. What goes here is a positive. This is going to be to subtract. This cancels to 0, and I have negative 11 equals. And when adding and subtracting integers, as we are doing here, when the signs are opposite, one's a positive and one's a negative, you need to subtract. So I'm going to subtract. 15 minus 3 is 12, and 15 minus 4 is 11 over 20. And notice that here the negative is larger, so this is going to be a negative here. Negative 12, 11 over 20. And we want to get rid of the negatives, so I'm going to multiply by negative 1, because when you multiply by 1, the value won't change, but the negatives will give us the positives that we're looking for. And both ways we get the same answer, 12 and 11 over 20 yards. So that's how much the designer has left over. Thank you for watching educator.com.